Thank you. No more question? Any other question?
Sir, I have a question.
Yes, please.
So in this project, you give us a power rating for each generator, not a complex power, a real power.
Yes.
So when we're finding the regulation constants on the denominator, we're supposed to take our real power and divide it by our per unit, right? Sorry, our power factor. Sorry, our power factor.
I'm sorry for the previous one. I assume one question, and then actually the question is asked for something else. Let me be clear, so I will not confuse you. Okay, now you are talking about the joule rate.
Yeah.
Okay, the joule rate. The joule rate is you have to convert it to the common base. Otherwise, you cannot do it because you want to do them together.
Yeah. So doing it on the common base, you take your new S, so your new S base, and you divide it by your old S base. But we're given.
Don't try to you remember the formula and then express it. If you believe the formula is correct, just use it. If you don't believe it, then you use the basic engineering reasoning. Okay. Now how is the basic reasoning? The per unit is based on some base, and then now the base is changed. So first you want to use your per unit multiplied by the old base, become the real unit, and then divide the new base. Just use the reasoning. Either two ways to do it. One way is if you believe the formula you have is correct, then just use it because it's correct. But if you have any doubt, then you convert into real unit. For example, if I say is five per unit resistance, okay, now the base change, then you multiply by the base. If the base is 10 ohm, then you convert it to 50 ohm. Now the new base is 20 ohm, then the 50 ohm divided by 20 ohm. Don't try to remember try to reasoning of the equation. If the equation is not correct, how many reasoning it does not help you. If you believe if you have a confidence the equation is correct, just use it. If you have any doubt, convert into the real unit, and then divided by the new base. Okay.
Right. So in your lecture, you did go over an equation that was in the textbook.
Okay. You ask yourself what is the real unit, then you multiply by the old base. What is the new per unit divided by the new base? That's it for everything.
Okay. So there's only one right answer to this question, basically. And what I'm trying to get at here is there's a formula that you did teach to us from the equation.
Is the formula correct? Use it. If the formula is not correct, then get the real unit and divide by the new base.
Okay. Okay. Thank you.
Okay. Thank you. No, I just try to because a few years after graduation, and you try to remember which multiply by which and divide by which is dangerous. It's dangerous. Okay. It's unless you find the textbook while you are doing that in your engineering career, you find the textbook, you believe the equation is correct, and just use it. But don't try to remember I multiply this, divided by this is dangerous. Once you remember wrong, your whole design is wrong. Put it back to the real unit and divided by the new base. How to put back in the real unit is the old per unit multiplied by the old base. Then become the real unit, real. And then divided by the new base, then it's a new per unit.
Yeah, so you give us the real units, you give us megawatts, right? And we're given a common base of megavar. So, sorry, MVA. So my question my question to you was just to get that
Okay.
I guess it would
Okay,
be old phase.
second question. That's the second question. Okay, that is the second question. The second question is when you control the generator, you are not the control. That is something I have mentioned so many times in the lecture. Is we have to be clear. Okay, now you are control the real power, the reactive power. The appearance power is composed of two things: active power and plus reactive power. Reactive power is from the excitation, has nothing to do with the steam, nothing to do with the real power. Now you are talking about where you are controlling the real power. So you only use the real power. Forget about the reactive power. You have nothing to do with it.
Okay, I see. That answers the question.
Okay, that is what I'm saying is power engineering is so simple, but it's so simple to make mistake, and the consequence is so huge. It's not like other subject. Other subject is so complicated, maybe, but power is so simple. Once you know, you enjoy your whole life, whole career. I mean, but if you do it wrong, then the consequence is huge. Now you are controlling real power. Has anything to do with reactive power? Then why ask appearance power? I'm telling you, my memory is so little, my intelligence is so low. I'm doing so successful because I just remember very few things. I go to say, okay, this is control real power. Why should I worry about reactive power? Why should I worry about appearance power? Okay, I'm not smart. I'm really, really dumb person. I just know that you control real power. Why should I worry about appearance power? I don't care about what is the formula because it's not related. Where does the reactive power come from? The reactive power is come from excitation. Now the generator has excitation, has real power. That's why you have appearance power. You have to understand the basic because only 1 month away from your graduation, and no one will help you. No one will help you afterwards. And you may be the only electrical engineer in your whole company. Don't try to rely on it. Rely on your basic. Okay? I'm sorry I'm putting a little bit stronger word because I'm worried about people. I'm worried about our repetition. And that's why the Ryzen graduate is do so good. Because we only need very little to do so successful. Very little. I don't need to, why should I worry about appearance power? It is control real power. Okay? I hope I answered your question.
Yes, you did. Thank you, sir.
Yeah, thank you. Yeah, please ask question. We are discussing, and I'm only in the purpose of just because I worry. That's why I become putting a very strong word is because I worry. I want you to be very successful, because Ryzen graduate from power is very successful in the industry. Very successful, not just successful, very successful in general. Okay, so when you step out, you have a full confidence. You graduate from this course in power system area, you have no problem. But don't confuse yourself. Okay, you are doing with real power, then doing with real power. You're doing appearance power. You are doing new base and old base, and don't try to remember formula. Because a few years down the road, you remember formula and try to do your design is really dangerous. Formula is so convenient to do an exam. So convenient. Okay? I'm not opposed to use it because it's so convenient. Okay? But any doubt, go back to the basic. Any doubt, go back to the basic. Okay. Any other question? Never mind. I may make some comment that on a good purpose. Okay. Please understand that. Okay. Ask any question. It's not recorded. So please ask any question. Any question. Anything. Okay. If you may interrupt me, and if you don't have any question, I don't want to just keep on waiting. I will give a quick review, and you may want to drop down. You may want to drop down the logs. Okay, I let you to drop down the logs. Okay, I want to do it for everybody, so it will not be turns out to be unfair or not, or all these kinds of things. Okay, as I mentioned in the in the final exam guideline, everyone has to read your student card to make sure the question you match, because I don't want the funny things happen in like a midterm. Okay, give me the answer, but from the derivation I cannot get the answer. Okay, I cannot get the answer. So I try to yeah, I do a lot more work to produce a few exam. A lot more work in the sense of it's not sort of question. It's just to make sure the question are equal weight. Okay, so number one, and in each question I say clearly. It cannot be say I miss it. I ask you to bring your student card and read your student card. If you can, I'm telling you that is really will happen in Boost Power and Pickering. And people are so confident. They just go to cut the meter, cut the things, and without read properly the station number. Okay, if you cannot read your student number and answer the question, then it's better to fail now than it's so difficult to get a good job and get fired. Okay, so even I do a lot more work, but I still want to be a fair exam. Okay, so it's according to your student number. Second, in the study guideline is the first set of the question are short question. For example, what is the optimum power? What is economical dispatch? And what is the optimum power flow? And the power flow, what kind of method is using it? It's a general question. What is recursive operation? How it coordinate with the fields? How it coordinate with the upstream, backup breaker, and what is line to ground fault, line to line ground fault, and this kind of things is people will ask you all the time during your career, if you spend a career in power. Okay, and the generator, when the load is suddenly increased, and what happened and how you restore it, it's a descriptive. And the traveling wave, why we are doing the traveling wave, because we want to see what is subtransient up and stress and the insulation coordination. You don't want the the equipment you connect is under stress and finally it failed. Okay, all it has a reason. Okay, so that is the first question. The second question is the detailed calculation. The second question, third question, and fourth question are detailed calculation. Detailed calculation is ask you what is a traveling wave, reflect it back and forth, and if you have a transmission line, then you can find the inductance and the discrete inductance and capacitance and how you find the traveling wave and all this. All this is very basic things. Okay, so just try to make sure you have a preparation for that. Okay, and then the third question is the same as your project. I'm similar to your project number 3. It's talking about the transient. Okay, if there's a fault in the middle, a fault on the bus, a fault in the middle of a power line, the power is still going on, so it can last longer. Okay, it can even the fault here later, it may be still stable. This calculation. Okay, and if it's ground on the if there's a fault on the bus and it may cut off the power during the fault, so it will accelerate much higher because the electrical is go to 0 because it cut it off, and the input power from the generator is continuous, so it accelerates. So the rotor runs faster and faster. Okay, and then when it release, and it become at that time is acceleration. When it release is deceleration. Okay, so what else? And then the droop rate. The droop rate, if it is suddenly increase or decrease, we worry about whether you reach the generator limit. If you reach the generator limit, and if the question asks you not exceed the limit, then that generator will fix on the maximum, and the other generator will the other generator will pick up the increase of the load. Okay, if it's decreased, then we are not worried about that. If the power system is already under balance and suddenly the load decrease, okay, the load decrease and the frequency will increase, and how you restore it is the same as your test project number 3. So it's not the question is the question in the final exam is reasonable, but I would say if we are overlooked, then you may have to come back another year. Okay, so I don't want this happen. So please be prepared. Okay, and that is project number 3. It's not something okay. I never do it before, and you are kidding me. You try to school us. No. Okay. Now, for the fourth question is similar to your project number 2. Okay, it's similar to your project number 2. The recoaster coordinated with the fuse and the backup upstream breaker. Okay, so and how to coordinate, you have to read the instruction, because the instruction is assumed this is how it's set into the this is how it's set in the relay. So read the question, and this happens every year, particular open book. People will copy the old one. For example, I say the coordination is 0.7 second, and in the project may use 0.5, and people just use 0.5. They will not read the question. This happens every year. Every year, not many students, 2-3 students will just copy from the project, from the things, and put it there. Please, that's particularly in power. We are very simple area. You enjoy the career, but you have to be very careful. If that is the setting, then we have to respect it. If the setting is 0.6, if the setting is 0.6 second, then it's 0.6 second. Okay, okay. So make sure that so for project number 2, project number 3. Okay, the project number 2, number 3, then we have been spending so many time. Of course, those are related to how to change the base and all this. That is what you learn in the junior course. Okay, so anything else? I would say the exam is fair, but for unprepared, that will be dangerous. Okay, that will be dangerous if for unprepared. Okay. Okay. Now, any question? Any question? So I repeat. Okay. The first question is what I mentioned about those the descriptive. The descriptive, because why not numerical? Because most of the time, 99%, you don't need any calculation. You just go there to do a reasoning. Okay, particularly in why I say 99%, a lot of engineer graduate, they go to project management, go to move the project and all this. They have nothing to do with the technical side. They need to aware of it. That's why the first question is important. Is because I ask you to aware of this. What is the topic? If the basic, you may, if you are more in the design department, most of the design, particularly in utility, are done by some big company. Okay, they just buy the equipment. The engineer is to comment on to look at the design whether it's right or wrong. So you have to have you don't have to do the calculation. Basically, you may do some checking. Okay, so the basic is very important. Okay, to create a design is a lot of time is done by the utility, by another group of person. Okay, is most of them is not. That's why I want to put the first question is the basic. What is Gauss Seidel? What is Newton-Raphson? Okay, and what is economical dispatch? How economical dispatch is done. Okay, so let's take, if no question, let's take 5 minutes, and then I go to I give you a chance of 5 minutes to think about what. Now you know the area of the question. I give you 5 minutes to think about what question you want to ask. If you don't have any other question, I will pull the two project and review the two project to make sure you're okay. And also I do some example and all these kind of things to make sure you are okay. Okay. I want everyone successful. Okay. So let's take 5 minutes or to think about in this area what question you want to ask. Okay. Any question? Any question? Okay, maybe I go through the key parts. I just want to make sure we just review. If we just review it, okay? So it's not giving us something special. It's not giving something special here. Okay, just try to make sure. Okay. So I try to be fair to everybody, whether you attend the lecture or not. Is still fair. Okay, let me do some. Let me do something. Okay. Yeah, I'm begging for everyone to come, and if they don't want to come, there's nothing I can do. Okay, nothing I can do. Okay, since this is not a personal question, I want to put it into recording in case of someone who has a very good vision of not able to come. Okay, just try to be as open as possible. Let's see how. Okay, I put it into recording because it's not your personal question.
Recording in progress.
Okay, for project number 2. Okay, and that is one of the vision. Let's look at that. This is okay. Let's do this. Okay, you have all done this. Just try to reconfirm everybody is on the same base. Okay, for example, in the line to ground fault, and now we have two fast recursive curve, 2 of them. Which one we should use? Then because it's line to ground fault, we are using the ground one, not the phase one, Okay, so when the fault occur, the fast one will open up because there is a ground. So it will open up at 0.07 second for this ground fault level. Okay. Now, if it's just a flashover, if you don't open it, then because your source is still provide the current, so it will not. It may not. Most of the time, it may not go away. So you have to open it, cut off the source, because it just flash over. Okay, it's not some conducting path built up, just flash over. And once you cut off the source, then it will be open. So if it is flash over, 0.07 second open, and then you close it again, and the system will recover. Okay, but I'm talking about this green line. Okay, but if it's not, it's a permanent. Okay, it's permanent fault. Now for someone we have to understand a little bit here of the design concept is we are talking about the fault is here. The fault is at the other side of the cake of on the low side of the fuse. So the fuse will protect it. And why we calculate is always we calculate, say for example in the bus 8, because it's from the fault current calculation, the impedance in between this is so low. So just for convenience, we calculate the fault in this bus. Actually, it should be calculated the fault in this, if the fault is here, it should be calculated the fault in here. But we may not have the data. We may not have the data when the fuse is good and the resistance is so small and all this. It does not affect. That's why for convenience, we assume the fault is here. Okay, it's the same as the fault is here. This is a convenience calculation, and this is actually happened. But the two value comes out to be equal because in between the impedance is so low. The same as a lot of people is talking about is when we sometimes when we calculate the things we are calculate. For this case is okay. For this case, the breaker you calculate the fault is here. That's okay. But if the breaker is here, very close to bus 7, so it should calculate the fault on the low side of the fuse or of the breaker. It should be like that. But for convenience, we calculate here because in between the impedance is so small difference. So someone asked me a question in the email and all this, why we do that? It should be on the left-hand side and the right-hand side. It's indistinguishable. Because, or even if distinguishable, the difference is so small. And we may not have data to make it more accurate. And even for the more accurate, so what? Practically your relay is not set to the decimal place. Okay, so just try to clear up this concept. Okay, another question is, I have a fault here. Okay, and or I have a fault here. So sometimes we say, okay, in order to coordinate, we will say, okay, what is the chance for this recoaster to clear the fault? And then we add a margin such that it will not be overlap of open. Because overlap of the open, then that means you open more than is necessary. That means you cut off the surface to your customer. Okay, you cut off, you lost revenue and you lost repetition, and also the regulation. If you do that more often, the regulation will come to ask you, well, you take people's money, but you are not providing the service. And the regulator, most of is a government agent, will come to after you. Why your control is so bad? Okay, and you always interrupt the power, and the people has to lose a lot of money. Okay, So you have to provide as much surface, maintain the surface as much as possible. At the same time, you have to protect against of damage. Okay, so you have to make the balance. Okay, so for example, if the fault in here, it will open. This is the fault current. If we open at this time, say T1, and this T1 is for this breaker. Okay, it will open. Then you build in some time. Okay, you build in some time, so you have a coordination time. So T1 plus a T coordinate. Okay, so you have this time. And then you design what will be here. If you say, okay, this is the T, the dial setting, and then you say, okay, now this is the fault in number 8. Now if the fault is in 7, so it will be more in 7, then you do a coordination. You will say, oh, this doesn't work, because from this time, and you add the coordination, then it will operate here. Then you have to find if you have to react faster because it's larger fault, you have to pick another curve. You have to pick another curve. You have to pick another curve such that it will be operate earlier. Okay, so but in the exam, I will not ask you to do that because this kind of design will take time to come up with a good design. So, but someone asked in the email, say, okay, and I'm not happy after the coordination, the time of reaction is too slow. What should I do? Okay, then you pick another curve. Pick another curve because no one say you have to have a particular curve. In the setting, you can pick another curve. Okay, thank you. Okay, let's go back to a few things you need to work. You need to pay attention in your final exam. You have to pay attention in your final exam. Okay, if the open here doesn't work because it's not a flashover, then you will wait for the fuse to blow. So what fuse you are talking about for this is we are talking about the fuse is 100. The fuse is 100. So you are talking about this two curve. Okay, so then in this curve, it will melt in here. So it takes 4 seconds to melt. When you are applying this current, it takes 4 seconds. So if people will ask you, watch out, okay? If people will ask you, what is the time the fuse blow compared with the fault first appear? So the answer, how much time it takes the fuse to blow is 4 seconds. How much time or when the fuse is blown up to clear the fault? It's not 4. It's 4 plus, first is the 0.07 second is the fast opening. And if the fast opening is does not work, then the breaker will close again. Say if the breaker close again for 0.5 second, that is how to get 0.5 is what you program. Okay, what you program into it. Okay, or what you set into the relay. Okay, so when the fault occur here, a permanent fault, it will open, but then it will close again. So this is open, and then this is closed again. After it closes, then it takes 4 seconds to blow the fuse. So when the fuse will blow is 4.57 seconds after the fault occur. Okay, again, try to read the question. Don't pre-program your solution. Okay, this is the answer, and make yourself open. Read the question. If it say 0.6, then this is 4.67 seconds. Okay. Now, whether the fuse is, if the fuse is blown, that's okay. If the fuse is stuck or the path is bypass the fuse, you have in your electrical path, you have the fuse here, but the fault is called bypassing. So the fuse will not, the fault will be going in this way. Has nothing to do with the fuse. It bypass it because a pieces of metal fell caused something. Okay, okay. For example, this is the fuse box, and the cable is come to the fuse box. Okay, come to here. If the metal fall in here, then the fault will be bypass the fuse. So the fuse will not blow. Okay, then it will open again. For this case, it opened 15 seconds again. Now ask you what is the time? What is the time the relay? What is the time of the relay? We'll ask the recloser to open. Then you have to add. You have to add the 0.07 for this case. Is the fast open, and then the reclose 0.5 or 0.6. Then you add them together is 15.57. So read the question. What is asked? Very important. What is asked? Okay. So just try to point out this. Okay. Anything else I need to point out? Okay. Okay, for the phase is higher is the same argument. Same argument. You pick another curve, not for the phase one. Okay, and then the fuse will go in here much faster. Okay, and so on. So anything else? Okay, based on this, any question? Any question? Any question? Okay. And the requirement, another thing is I want 4 Saluton digit calculation. 4 Saluton digit. And the calculation The exam question now is recorded. The exam question is according to your student number. So you have to bring your student card. That is a policy of university. You cannot say I forgot. Okay. Okay. I just say, oh, okay, I remember wrong. No excuse. Okay, no excuse. So you have to know your student number. Okay, you have to know your student number. Okay, just try to do the exam. Try to put some safeguard to the exam integrity. Even I have to do more work to set the question. Okay, before I move away from this one, is any question? Any question? So
Professor,
yes, sir.
I just have a I just wanted to summarize, just to make sure. So, firstly, the fast recruiter is gonna operate, and then and then the fuse, and then after the delayed recruiter. That's being the steps. That's how it's gonna operate.
Read the question. The question will tell you the sequence. If
Yes.
no one tell you, you can make any assumption you want. You just say your assumption.
Oh, okay.
So it's not, I don't want to give you the direct answer. It's because there's no direct answer. You read the question say this is how I set in the relay. And you come to do the analysis. Then you have to respect the setting. Okay, read the question. The question say, okay, it open, it open, most of the open is depends on the fault. And then after the opening, so then there will be a time in the relay. There's a timer. The timer will come to your setting, and then it will open again. Okay, so you, or it will close again, or it will open again. So to advise you is, don't pre-program yourself. What is the sequence? Read the question. That's most important. That is the most important for. That's why I say the engineer can do very successful without a lot of intelligence. Is be careful. You don't assume. Oh, this is what I learned in the school. It must happen this way. No, read the. When you're working in the site, read the manual, read the instruction, read the setting, read it, understand it, and then take action. Don't assume this is how it operates. I learned recoding in the school, and it has to be happening that way. No, if the setting in your company is different, it's different. If you don't like the setting, then you change the setting. So to answer your question, is it this way? I say, I don't know. Read the question. The question say, is this 0.6, 0.5? This is a sequence of open and close. Then do it. Even you don't like it, even you disagree with it. Okay, in the exam, you accept it, and then you complain it afterwards. If you are right, I'm wrong, then I give you everybody's bonus. Okay. So to answer the question is, read the question. Read the question. If the question is this sequence, accept it. Even you don't like it, and then you can complain afterwards. Okay. That's what I want to tell you is why every year this will happen again this year. Someone will not use the instruction in the exam. Will use the instruction in the project and to answer the question. Just like the people in boost power, they go to cut the meter. If the meter wrong in station 3, they will just walk out the aerator from the engine. The fourth unit fourth is the closest. They just go there to cut the meter. Okay. Then you're lucky it's not fire. Okay, you'll be lucky it's not fire. Do you know how difficult to get a good job? Make sure you keep it until you find a better one to replace it. Okay, don't be fired because of the small things you overlook. Is you don't need a super intelligent to read the menu, to read the instruction. I believe all graduates from Ryzen, they they can do that 100% correct, 100%. The people don't do it right is because they overlook it, they overconfidence, or they are lazy, or they whatever stuck in the mind. Okay, at that time. Okay, so is your career once you fire from the company, the record is damaged. It's difficult to find another one. Okay, so don't let that happen. Don't let that happen. So to answer your question is read the question. What the question say? When it open, when it close. If it open, depends on this. If it close, is after this. Read the question. Okay. Any question before I move this? Now you promise me you can do this. Okay. I just asked this. You promise me you can do this. Okay. So since not much, let's take a break, and then we'll come back. Okay, come back another 2 3 minutes.
Recording stopped. Recording in progress.
Okay, let's continue. Another question is similar to your project number 3. Okay. And is quite one thing I want you to watch out is to see which one of the generator will be exceed the limit. Okay, for this case, for example, 3 of them are not, none of them are exceed. But if the load increase more, and some will be exceeding. And for example, for this one, if the load increase more, then this will be exceeding its limit. Then the other 2 not exceeding will carry the increase. So this is something I ask you in the final. Okay. Now another question is try to tell you to illustrate you really understand how the generator is controlled, the willpower, how the willpower. Okay, the first curve here is just to illustrate the setting of the joule. Okay, 4% means is at the maximum power, or at the rated power. For this case is 300 megawatt. Is running at 60 hertz. When the output is 0, then the frequency will build up to, the frequency is supposed to build up 4%. So then you have 2 point, you can draw a straight line. Okay, 2-point form you learn in grade 12. And that, so it will, but if the load is demand is less than the maximum, and you still try to maintain this joule rate, that means maintain the slope. One thing I want to I forgot to mention again is, please, if you have a printer, print a field curve such that you can use in the exam. But I know people will argue to the death, say I don't have a printer. That's fine. You don't have a printer, it's fine. If you don't have a printer, you can do 2 things. One is sketch before the exam, or sketch during the exam. It's up to you. It's your freedom. But you need to sketch such that I know how you get the operation time of the relay. When the fuse will blow, and you need to indicate. You can sketch. Okay, so I don't want to go to the argument is I don't have a printer. You don't have a printer, that's fine, perfect. You don't have a printer. That does not mean you cannot sketch it. And then you say, oh, I sketch it in this time, then you sketch it now. Okay. So make sure what curve I should sketch now is the same as the textbook. Okay, so you sketch a few things, and then you can use it in your exam. But if you say no, I'm busy, I don't do that, then do it in the exam. Okay, if you don't do that, then you get no mark. That's it. Okay, engineer try to try to meet the environment as much as possible. If you say keep on telling you I cannot do, then that means this may not be the career you want to spend the time. Okay, maybe you do some other career, you will be more successful. Okay, so just want to make sure. Why I need to sketch, because first I need to understand how you get it, and the second is just giving me a number, then it's very easy to transfer by all means. Okay, I don't want to speculate. Okay, I just want to make sure it's your work, and also your after you sketch it and you go through your thinking process, you will be more accurate. Okay, so just want to make sure. Okay, no sketch, no mark. You can use your printer if you have a printer. If you don't have a printer, you are not forced to buy a printer in the pandemic. Okay, you are not forced, or you don't have the money. That's okay. I know we have all kinds of condition happens to an individual, but does not mean we cannot ensure the correct design. Okay, just put that in record. Okay, so originally in 60 hertz is operate at, for this case is 180 megawatt at 60 hertz. That means you are work the generator power control is operating in this curve. Now if the power increase, so the power is moved to the higher, it increase. Okay, and after the calculation, you will find out the power is the power become 268.7 megawatt, and the frequency is lower, 59.29, and the low is not a fixed low, because actually it will go back and forth around this line. After it settle down, then ISO will send a signal to everybody in the system. Everybody will adjust your reference to bring it back to 60 hertz. And you bring it back to 60 hertz, you still produce that much power, but now it's in 60 hertz. That means you are in this curve. Now it's operating this curve. Now if the low, now your curve is here. If the low is reduced, say it reduced to 200 in the new one, now the system is operating higher frequency. This is higher than 60 hertz. It operates there until ISO to say, okay, let's readjust it. And you readjust it. Now in the 200, you readjust back to 60 hertz. So this is how it operates. Because the low increase, low decrease is random. So we cannot adjust it continuously. Okay, you still can share the power increase or decrease according to the rating, the capability of the generator. Okay, so it's moving, and now, for example, it's a peak time for the system. Now the frequency drop down too much, and ISO to say, okay, we foresee the peak hour will be last for three hours. Let's adjust it. And then when Then in the lower power output, and the frequency increase, then it will be adjust back. So we adjust back only at discrete time, but continuously adjustment is based on the curve, and the curve is according to the capability of each generator. Okay, so just try to make sure you can do this in your exam. Any question? Any question? Hello, any question? I can give you 2 minutes to think about any question here before I move to another topic.
Recording stopped.
Okay.
Recording in progress.
Okay, let's continue for the similar to the question number 2. I use the last year's exam to illustrate. Okay. And the formula will not be given because it's open book. So this formula is going to be used, as I mentioned many times during the lecture. Okay. And so if you are given the inductance, capacitance, you can find the characteristic impedance and the velocity of the traveling wave is 1 over square root LC. And this is the time required to travel the whole length of the cable. So it's the distance divided by the velocity is time. Okay, so and then this is the reflection coefficient in the receiving end, and this is the reflection coefficient in the sending end. Okay, this kind of question is don't miss it. That's why if you prepare as we discussed today, so you can get very good marks. I want everybody to get good marks. Okay. Okay, let's do a question, because this is not in a project. You may not be familiar with. Okay. So you have a 75 ohm losses line open at the receiving end, and you have a step wave coming in, and the source impedance is 75 ohm, and ask you to find the general equation in terms of the distance x and the time t, the current and the voltage. Now to ask you to plot a distance L divided by 2, that means in the middle of the cable, and ask you to, because it's a traveling wave, it's in time, so it's not steady state. Steady state is one value for a long time. Well, this is always cover a certain period. For this case, it's from t to 2 tau. Tau is the time to travel for the distance of the cable. Okay, so this is the fixed distance and variable time. Now the second is fixed time. That means you are observing a certain time along the cable. So the time is fixed, but the distance or the distance is cover the whole length. So I'll ask you to pop this. So once you know it's nothing, but if you don't know it, try to figure out in the exam. It's almost, I can tell you, it's impossible. But once you prepare this, it's nothing. It's so simple. Okay, so then you can graduate from this course with very good grade. 48% is a large percentage. Okay, it's a step wave, 10 volt step wave. Characteristic impedance is 75 ohm. Open at the receiving end. The receiving end is infinitive. Source impedance 75 ohm. Source impedance 75 ohm. And this is just put into the formula. Just put into the formula. That's why to get this kind of question, you should get it 100%. Okay, and so easy. Just put into a simple calculation, and the sending in reflection coefficient. Okay. Now, and use this equation. Just plug it in. Step of 10, characteristic impedance, and the source impedance, and so on. Now it's changing from frequency domain to time domain. The S is basically is the delay. E to the power something is a delay. It's a delay. Okay. So here is x divided by v, a delay of x divided by v. X divided by v minus 2 tau. X okay, yeah. That's correct. Okay, that's correct. Okay, and then you have a formula. Similarly, you have a formula for the current. So you change into here. Now you answer the second question. At x at the middle of the line. So you put x. Become. So this is x divided by the velocity, and x is L divided by 2 velocity. L divided by 2 is tau divided by 2. So that means the delay is tau divided by 2. For this, the 3 tau divided by 2. When you practice, it's nothing, but try to figure out in the exam is almost impossible under the time pressure. Okay. Now, once you have the equation, now how to use this equation to sketch it. So you always put this equal to 0. Then t is equal to tau divided by 2. That means is at the time tau divided by 2, you'll see the step. So it won't see the step until time divided by 2, you see the step. So this step will be continued like this forever. Suppose by definition of step is continuous. Now at the tau divided by 3 tau divided by 2, 3 tau divided by 2, you have a reflection. And the reflection is positive. So you add them together. Okay, you add them together. Before is 5. Now you add them together, become 10. So the final answer is you won't see anything until tau divided by 2 in the middle of the line. And then you see the step supposed to be continued, but it has a reflection. You add them together. And this asks you to plot until here. Then you don't worry about later. Okay. Now for the current, after you plug it in, is 115 for this case. You will see the step. You will see the step only after tau divided by 2, you will see the step. But in the reflection, it is negative. So you add the positive and the negative together becomes 0. So the end result is, again, this is very simple. You have already done this in the junior course. Okay, this is nothing, but it may catch people for unprepared. Once you prepare, it's nothing. Okay. So any question? Now, for the cable length is L. So we are interested in plotting here in this L. Okay, and ask you at the time tau divided by 2. At tau divided by 2, and at different location. So at different location, tau divided by 2, you put it in, and use substitute tau divided, the t equal to tau divided by 2. So this is the, after you substitute the t, after you substitute the t into the t location, okay. Same thing is for the reflection wave. If you want to reorganize it, you can reorganize it. Okay. So, any question? So you will see the step. The step is 5. Magnitude is 5. At tau divided by 2, it travel L divided by 2, and it will continue. But it's not yet because we only asked for this time. Okay. Now for the ramp function, ask you for the ramp function, 6 volts per second. Okay. The ramp function from the Laplace is divided by s squared. So you just change into the Laplace first and use the equation, do the same thing. Now this time is voltage, current, then read the question. The question asks you at the length of, at the distance of L divided by 2, that means at the middle of the cable. So we take tau divided by 2 to start the ramp function. And after the reflection, they add them together. So it will go twice of the slope. And this is the ramp for the current. The ramp function is like this, but the reflection is negative. So it cancel out this part like this. So this will be like this. Again, it's nothing for a 4th year student. It just may catch in a surprise. Not if you don't prepare for that. It's not something you cannot do it. I'm sure I 100% you. This is nothing for you. Nothing.
Hi, Professor.
Yes, yes, sir.
For question number 1, part C, for the plot, how come the plot dropped to 0 at L equals to 2?
Because it takes time to propagate. It takes time.
Because based on the equation is, well, it looks like it's gonna plus 5 again at L equals to 2, no?
L over to 2 is 5. But before tau divided by 2 is 0. The step wave has to propagate, has to go and reach there. This is in the middle of the line. The step wave is coming. It take tau divided by 2. It start to reach the middle of the line.
Yes, that's right. And then I'm talking about part C though. The plot for part C.
Part B.
So question 1, part C, the plot.
1, part B.
Part C, C for Charlie.
Yeah. It's already. I mentioned about part B.
I was referring to part C.
Oh, part C, not part B. Okay, part C. What is a part C? The question first. We always refer to the question. The question is at the time tau divided by 2. At the tau divided by 2, and pick one point. Pick the critical point, then you can draw it. Okay? When x equal to 0, you have the 5 because you start to see the step wave, and then you pick another point at the middle of the line. You start to see, so you can draw it. Afterwards, for here is still 0 because the wave has not propagated yet. Okay.
Okay, thanks.
It's propagating.
Thank you, Professor.
Okay. Thank you. Okay, I have nothing more to remind you. It's pretty simple. It just need to be a little bit more careful. That's all. So you can say it's a difficult exam if unprepared, or easy exam if you prepare. But definitely will be for not well prepared will be difficult and very busy. So if you prepare the project you have already done for several weeks, and only for this travel wave, again, it's a travel wave. It's simple but easy to make mistake. Just easy to make mistake. That's all. It's not a difficult one. Okay. So there's nothing I presented, so I stopped the recording. So you can ask your personal question.
Recording stopped.
You can ask your personal question. Okay, if not, then good luck in your exam. If no question, I'm not going to answer email question related to the final exam because in all question is so close to the exam, and I can ask in the class. I can answer in the class, and that means everyone get the same message. I'm not going to answer specifically to an individual. Okay, so we
Can you
have
actually,
time.
can you go back to the previous question you were just doing?
Pardon me?
Can you go back to the previous question?
The previous question, which
Yeah,
one?
the exam.
Oh, the exam. Okay,
Yeah.
sure.
For the equation that we get for 1c, you see how it's 5u L minus x over v? Right, we divide by v. Why don't we scale that graph? Because normally when you divide it would be an expansion, right?
You're talking about A part or B part or what?
C.
C. Okay, let's try to see. So the C part is at the middle of the line.
No, it's at t equals tau over 2.
T equal to
It's time based, not not like location based.
Okay, very good. Okay, C part at tau equal to 2. At tau equal to 2. So the wave is, okay, at x equal to 0. Do you agree you see 5 volt?
Yes.
Okay, you agree. Okay, you agree with that. So, and then as time goes by, then this is propagate.
Yep.
Okay, it propagate and at the middle of the line, the wave is propagate with tau divided by 2. So the step is just reached here. The rest of the line still don't see the step yet. So we still see the wave is coming, but it has not come yet. That's why I use the dotted line and arrow.
Okay.
It's not right. It take more time to reach.
Yeah.
Thank you. Yeah, thank you for asking this question again. I think someone want to yeah. Thank you for asking this question again. So try to explain it a little bit better because it take longer time. I only interest in the time divided by 2. If it's equal to tau, then this is go to the end. The step is already go to the end. Okay.
Professor, can you please go down a little bit?
Go
Scroll
down.
down a little bit.
Go down here.
Question 2.
Question.
Plot. So for the plots here is we're interested in the slope, right? So are we just directly adding the slope after, well, in this case, 3 tau over 2, right? So we're just adding, so the total slope would be 9.
Function. You're adding a ramp. How you add a ramp? You have a ramp here. you have a RAM here, and you add another RAM. Okay,
I see. I see.
then
So
you
instead,
add, of course, it is adding the slope just for simplicity. But the actual one is you are adding 2 RAM.
that's right.
You are adding this RAM and this RAM.
Got it. Thank you.
My friend, engineering, power engineering is so simple. that's why a dummy like me can do well. Okay, there's no thinking, no deep thinking. I mean, no deep thinking you need. If it is a RAM, if it is reflecting, then you add the refreshing. If it is a RAM, you add the RAM. That's it. If it's a step, you add the step. Nothing to think, right? Nothing to think. Or very little thinking for this, very little thinking. That's why how can you miss it? Okay, you cannot miss it. That's why I'm lucky I pick power. I have a beautiful life. and you're picking power, you have a beautiful life too. And
This is more related to the exam structure itself. So, well, based on this PDF you're showing, there's only 2 questions, right? But you also mentioned that there will be 4. So is it in the case that you'll be picking 2 questions out of the whatever amount of question you? So yeah, so each exam will be 2 questions. This is how it's structured.
You don't need to repeat. Okay, I repeat again. First question is descriptive. Second question is something like this kind of travel wave. Third question and fourth question are supported 2 and 3.
Okay, got it.
Do we need to repeat this?
No, I got it. It's just kind of like comparing the structures. I mean, like based on what you're showing us, right? Okay, I understand. Thank you.
Okay, very good, very good. The more important is you understand. Because sometimes I don't know how many times I need to repeat. So I may not see you all again. If not, it's good luck for your exam. Good luck for your career. And very soon you will find out you pick a good area. You will put a good area. Enjoy your life. Okay, and these kind of things will not happen. Will not change. Well, virtually not change for the rest of your career. Because unless it's the superconductor come, and it won't come, so it's not like the other area it changes all the time. This I think it won't change. Okay, it won't change. You just need to be careful and make sure you protect human, and then protect the equipment. Make sure your boss earn money, and then they can keep you. Okay, so good luck for everyone. So for those, I know you are very busy, and if you don't have questions, you can leave. Okay. If you have complained, you complain now. It's not. Let me make sure it's not recording. Yeah, it's not recording. You can complain. Okay, nothing more I will say, and if you have nothing more to say, then you don't need to stay. Okay, it's up to you. You don't need to stay.
Professor, just one more question.
Yes, sir.
So for the on project number 3, right? One of the question was asking if the fault happened on X14B.
Project number,
Yeah, project number 3.
project number 3. Ask you the form. Are you sure?
Yeah, if a fault occurred at the middle of X14B.
Project number 3 does not ask you anything about the fault.
Question 1. So on the project number 3, question 1, part
okay.
C.
Okay, I don't know why I put the protection there. Okay. Okay, that's fine. Okay. Oh,
Okay.
oh, I mean, okay. So what's your question?
So if so if the line, I mean the fault happens at middle of X14A, how would you approach this question? I mean, like the way I'm kind of thinking about.
In the middle. Okay, let me share the screen. Okay. So if the okay. If the fault is in the middle, so what is your question?
How would you approach this question?
This is the same as your midterm. This is the same as your midterm. Okay.
Okay.
With the midterm, okay. Now it's easier to see from the midterm. In the midterm, let me see. I have the midterm solution. Midterm. In the midterm is you. In the midterm is okay. Let's read the question. At the middle of the line, a fault occurs in the middle of the line 1. So how you get it? You have a fault here. Find the difference. So the power, you find the difference equivalent impedance. Or looking from here, looking from there. So the focus is here. You have half of the impedance, XL divided by 2, and you have the impedance XL2. Okay, find the impedance. You ground here, you ground here. So you have ground here, you have ground here. What is the impedance looking from here? Is XL1 divided by 2, XL2, they're in parallel. And then you add the impedance of the transformer, add the impedance of the line, the transient impedance of the generator. And then you find the voltage, Thevenin's voltage. Okay. In the Thevenin's voltage, you have a voltage here, infinitive, and you have a voltage, the ground here. You have a voltage divider. Okay, so you have the impedance XL1 divided by 2, and this is voltage in the infinitive XL2. You want to find what is the voltage here. It's just a voltage divider. This divided by the sum of this. This divided by the sum. This divided by the sum. Voltage divided. And then the two voltage multiplied together divided by the impedance in between and sine of this angle. Okay, what else you want to ask?
Thanks.
Okay, thank you. No, please ask. I just don't know what I can say. Okay, it just please ask. I don't mean you don't ask. It's just what else you want me to care for. I'm happy to answer any question. I just don't know what you don't understand, and please interrupt me.
Can you scroll down a little bit, please?
Okay. Any question? Or you just want to take a picture?
Yeah, I just like to make sure to
Okay,
step
no,
up.
no, that's fine. I just want to know what I have to do. Okay, if you say I want a picture, then I move. Otherwise, I don't know what to say. I want to say something, but I don't know what to say.
Yeah, it's nice to be able to verify the methods.
That's
Can you please
good.
scroll down a little bit more?
That's beautiful. That is the whole purpose of this lecture. Just try to make sure everyone on the equal page and understand it. Okay. So
Hello, Professor. Hello.
Oh, I can't hear. Sorry. I mute. I
Yes,
keep
yes,
on
Professor.
talking.
Yes, Professor. I just have a question. In a matched load, why do we set the impedance equal to the characteristic impedance? Like
You speak a little bit louder.
in a matched load, why do we set the impedance equal to the characteristic impedance?
I really cannot hear. My ear is cannot reach your speaking. Can
Sorry.
you speak
Yes.
louder?
Yes, in a matched load, why do we set the impedance equal to the characteristic impedance?
I really cannot hear. Can you speak loud, very loud?
Yes, in a matched load, why do we set the impedance equal to the characteristic impedance?
Why equal to the characteristic impedance?
Yes.
That is the whole when we divide the equation in the whole chapter.
Yeah, I just want to know why. Why is that happening? Like, I just like I tried to search it up, but I couldn't find it.
Okay. Because then we have to go back to the. That's okay. Okay.
Yes,
Just
I
try to
just
no,
uh,
no. That's okay. Let me try to satisfy you. Okay.
thank you.
That's fine. Let me try to satisfy you. Okay. From this chapter 13,
Yes,
we start to divide from here the discrete component. V equal to L di dt, I equal to C dv dt. We understand this, right?
yes,
Okay, and then continue. Okay, then it
yes.
becomes a characteristic impedance.
So a matched load means it's. I just want to understand like the meaning. Well, the characteristic impedance means what?
Okay, first is you go through this. We agree with this. Okay,
Yes, yes,
and then we agree with this, and we give the name called characteristic impedance.
yes.
Okay, then it's characteristic impedance. We name it. Instead of always say square root of L over C. L over C, the unit is ohm. That's why it's impedance.
But what does a match?
Omega L,
Yeah,
omega C. Omega C you can write is omega L 1 1 over omega c. This is in ohm. This is in ohm square, but you take a square root. That's why it's ohm. Ohm is impedance.
Yes. But practically speaking, what does a matched load mean?
Match means equal,
So it means the impedance are equal.
and the impedance are equal.
Okay.
And it has a vision of matching is it will sometimes it have a reflection, sometimes it doesn't have a reflection. Okay, if
Yes.
the receiving end impedance is match the characteristic impedance, then the numerator becomes 0.
Yes.
ZC divided by ZC is 1. 1 minus 1 is 0. And I
Yes.
don't care about this what is the value in the denominator, and it's
Yes.
equal to 0. That means there's low reflection. The wave coming into the low, it does not reflect it back. You have to learn this in a junior course.
Yeah, but I forgot all of this. Sorry about that.
No. It's you have the right to ask the question, but I just wonder because this is supposed to be in the junior course.
Yes. Thank you. Thank you so much.
No, you have the right. This is the reason I'm here. Okay.
Thank you.
I just wonder why has this kind of question comes, because it's the traveling wave is already done in when you take the magnetic field. Actually, Ryerson, you take more magnetic field than other university. So I was thinking this should be very simple for you. You have already learned this many occasions. Any other question?
Thank you, Professor.
Thank you. Any other question? Okay, if not, good luck. So I can sign off because I don't know how many times I have to ask. Okay. So I presume that you are okay.